Welcome to 11.3, Simplifying Rational Expressions. In this section, what we're going to be doing is we're going to be simplifying any kind of fractions that we can. And the best way to do that is sometimes you're going to have to, or if you have monomials, you can cancel diagonally or up and down in like a regular fraction. Or if you have a binomial or trinomial, you are going to need to factor and then see if you have any common factors that you can cancel diagonally or up and down. So let's get into a little bit of vocabulary here. Because a rational expression involves division, we know that the denominator may not have a value of 0. So you can never have a 0 in your denominator of any fraction. It doesn't matter if you have like an 8 over 0 or if you have an x minus 8 over 0. Either way, you cannot have a 0 in your denominator. Any value that makes a denominator equal to 0 is called an excluded value. And anytime that a denominator is equal to 0, it can be called extraneous. Extraneous. Alright, so we're actually going to skip our first example of finding excluded values because we're not going to have to do that in your assignments, so we can skip here. So we're going to move on to simplifying our expressions. You can simplify a rational expression by taking the greatest common factor of the numerator and denominator, and your greatest common factor is the greatest number that is a factor of both expressions. So if we look at 2a down here, we need to simplify this expression. We have a monomial on top and a monomial on the bottom. So what we can do is we can cancel common terms on top and bottom. So you have a 32 and a 4. Well, if there's a common factor between those two, you can cancel them. So 32 and 4, each of those can be divided by 4, so you get a 1 on the bottom and an 8 on top. If you have an x to the 5th and an x on the bottom, the variables are nicer because you just look at the top and the bottom, see if you have more, where either in the numerator or the denominator. In this case, we have 5 x's on top and 1 x on the bottom. So we're going to cancel out the 1 x on the bottom, and we're going to cancel out one of those x's on the top, and you're going to have an x to the 4th. Now you get to your y's, and we have y's on top and y's on bottom. So we have 2 on top, but we have 7 on the bottom, which means we're going to be left over with 5 y's in your denominator. So your final solution of your expression after you simplify it is you have an 8x to the 4th in the numerator and a y to the 5th in the denominator. Now let's do the same thing here for letter B. For letter B, you look at your -7 and your 28. So we're looking at just your coefficients. We know that 7 does go into 28, nice and pretty. However, do not fall into the trap that a lot of people do by canceling and putting your bigger number on top. Over here, your 8 is in your numerator because 32 is bigger than 4. Well, in part B, 28 is bigger than 7, so I'm going to cancel out the -7 on top, and that's going to become a -1. And then I'm going to divide the 28 by 7, and that's going to become a 4. Do not automatically move your 4 to the top. So now let's go through our variables. So you have an a squared and an a to the 5th, so you have a to the 3rd on the bottom. And then you do your b's and your b cubed. So you have 2 more b's on top. So you have a b squared. So if we go ahead and write our answer, you can either include your -1 in your answer. You can say -1, ooh, that's kind of weird. -1 b squared over 4a to the 3rd, or the way you'll probably see it is just negative b squared over 4a cubed. So either way will be accepted. You just have to make sure that you cancel in your numerator and your denominator, cancel any common factors, and then you have simplified when you have monomials.